So we're going to be looking at the graph of sine and cosine functions in this lesson. So what we're going to be doing is using the unit circle that we studied in the past two lessons, most specifically the previous lesson, in order to help us find points and be able to graph. All right, so let's go ahead and get started. We're going to talk about the features of the sine and the cosine. Okay, so features of sine and cosine include domain, range, period, and amplitude. So the domain of sine and cosine is all real numbers. So from negative infinity to infinity, so it goes on forever in both directions. For the range, it's going to be between -1 and 1, and you're going to see that when we do the graph. The period is something that is periodic, means something that repeats. Okay, so sine and cosine are periodic, meaning that they repeat. Okay, so they're repetitive, basically. All right, the amplitude is basically like the height of the function, and it's half the distance between the base, the maximum, and the minimum. Okay, so it's the distance between the baseline and the peak or the trough. So it's easy to identify these from the function, so that's what we're going to be doing. Okay, so for the following problems, they want you to find the amplitude and the period. Okay, so simply to find the amplitude, you're going to look at the coefficient, so the number in front. Okay, so this guy. So, and it's always going to be positive, all right? Even if the value is negative, the amplitude will be positive. The amplitude is the absolute value, okay? So that means that the absolute value of 4/7 is simply 4/7, okay? So that's your amplitude. And to find your period, we'll call that T for period. So I don't know if I labeled that on here. So the period, I'll use the symbol T for the period, or I'll just simply call it period. But if I use either one of those, that's what I mean, the period. So the period T is equal to 2 pi divided by the B term. The B term is this guy right here. That's your B term. And I believe they use so okay. So that's sort of like our B term. And so 2 pi over B, and B is pi. So we're going to plug that in, and we get a value of 2 since the pi's cancel. So that's our period. All right, pretty straightforward. All right, so let's look at, so let me write the period equation on here so that you guys have it. So the period T is equal to 2 pi divided by B, okay? Where if you look at the sine and cosine function there, it's, so it's y equals a sine B times x plus c. Usually this is x minus c, but I'll just write it as x plus c plus d. Okay, so that's our generic sine cosine function. And so that way you know what a and b are. All right, so now amplitude here, pretty straightforward. It's the absolute value of -3, which is just 3. The period T is 2 pi divided by 1/2, because that's our b right here. When you divide by a fraction, remember to flip the fraction. So flip the 1/2 to 2/1. And then this is just over 1. You can multiply straight across. So it's just 4 pi over 1, or 4 pi. Okay? For this one, the amplitude is 1. There's an invisible 1 there. And then the period T is 2 pi divided by 2 pi over 3. So you're going to flip the 2 pi over 3. So that it's 3 over 2 pi. So the 2 pi's cancel. So your period is equal to 3. All right, your amplitude here, there's an invisible -1 there. So the amplitude is absolute value of -1, which is just 1. The period is 2 pi divided by, there's an invisible 1 there, which is just 2 pi. For part E, amplitude is equal to 5. Period is equal to 2 pi divided by 4/3. Go ahead and flip the 4/3, so it becomes 3/4. This is the same thing as 2 pi over 1. Okay, so this is 6 pi over 4, which that reduces to 3 pi over 2. Okay, so that's our period. Amplitude here is 1/2. Period is 2 pi over 4, and that reduces to pi over 2. All right, pretty straightforward to find amplitude and period. So to graph the basic sine and cosine, what you're going to be doing is you're going to obviously find the amplitude because that's easy to do, but find the period, because this is what's going to help you find the period t. This is what's going to help you graph it. Divide this period by 4 in order to get 5 points starting at x equals 0. So we divide by 4 just to get 5 points, because 5 points is usually a good starting point for graphing sine and cosine. Okay, if you want to get 6 points, you would divide by 5. If you want to get 7 points, divide by 6. But try to get a minimum maybe 5 points so you can get a good graph. Use the unit circle to get values of y. So this is where we use the unit circle right here. Remember that, okay, so it says get values of y. This should say get values of sine and cosine. Okay, so y and x. Okay, so on the unit circle, remember that the x coordinate is the cosine and the y coordinate is the sine. Okay, so in this unit circle here, I'll show you the unit circle real quick. So in this unit circle, you have x, y here, right? So x is the cosine and y is the sine. So in this case, the 1/2 here, is cosine, and the y square root of 3/2 is going to be sine. Okay, so that's what I mean by that. Okay. All right. So let's look at the following problem. So we want to graph 2 periods of y equals sine x. So the amplitude here is 1, invisible 1 in front of the sine there. There's an invisible 1 in front of the x there, so it's 2 pi over 1, which is simply 2 pi. Okay, so now let's go ahead. So now we're going to find. What we're going to do is we're going to divide. So this is what I call my interval. It's just something that I call it. But in order to graph it, like we said, one of the steps is get 5 points by dividing the period by 4. So we're going to divide the period that we got, which is 2 pi, and then we're going to divide by 4, and that gives me pi over 2 if that reduces. All right, so now we're going to do an xy table here. And so we're going to try to do, since we're going to probably have a total of maybe 9 points because we have 2 periods. So let's start with, since we have negative values here, we're going to do some negative values as well, okay? So we're going to start, let's say 0 in the middle, and then I'm going to go positive and negative. All right, so I'm going to do the positive first. So I'm going to add my interval of pi over 2 as I go down. So add pi over 2 as you go down. Add another pi over 2 because you're using this interval. So pi over 2 plus pi over 2 is pi. Add another pi over 2. Pi over 2 plus pi is 3 pi over 2. Add another pi over 2. That gives you a total of 2 pi. Now we're going to go ahead and take away pi over 2, or you can think of it as the negative of this guy. So negative pi over 2. Just do the negative versions, and that'll give you the same answer. Negative 3 pi over 2 and negative 2 pi. So basically you can think of it as taking away pi over 2 or doing the negative in this case. All right, so So let me do this in a different color. So this right here represents one period, and from 0 to 2 pi represents another period. So that's 2 periods there. All right, so now what we're going to do is we're going to use a unit circle. So we're going to want to do sine of 0. So sine of 0 from the unit circle. So sine of 0 degrees. So 0 degrees, this is a 0 degree line. Sine is the y coordinate, okay? So this is my sine. So sine of 0 degrees is 0. All right? So we have 0. Oops, wrong one. Over here. Sine of pi over 2. So sine of pi over 2, this is 90 degrees over here. The sine is 1. The sine is the y value there, okay? Now we want sine of pi, so that's sine of pi 180. The y value is 0. Sine of 3 pi over 2, that's down here. The y value is -1. And then the sine of 360 is going back here, which is a y value of 0. So we have -1, then 0. So it looks like it's doing this pattern where it's following the circle. It's 0, then 1, then 0, then -1, then 0. So it's following this cycle, okay? And that's why we call it a period. It repeats in a cycle. So -1, then 0. So then we can repeat this process. So 0, -1, 0, 1, 0. The next one will be -1, then 0, then 1, then 0. And it repeats that cycle. So now we can go ahead and graph it. So at -2 pi, we got 0. At -3 pi over 2, we got 1. Then we have 0. Then -1, then 0. Then 1, 0, -1, and 2 pi. Now we can try to graph this. Let me erase that part here. All right, and there's our graph. There's 2 periods of the graph. So this represents 1 period. One t, 1 period, and this represents another period. Okay, and the amplitude, that represents our amplitude, either that or that. So those 2 things represent our amplitude. All right, so in this case, the amplitude is 1, and the period is 2 pi because it's from 0 to 2 pi. All right, so that is the graph of sine. So now we're going to do the graph of cosine on here using the same process. So amplitude here, there's an invisible 1 there, an invisible 1 there. So amplitude is 1, period is 2 pi over 1, which is 2 pi. Oh, I forgot to do the even odd. Okay, so if you look at the example here, this is the graph of sine, but notice that this is symmetric about the origin because it's a reflection here, here and here. So this graph is symmetric about the origin. So that means it is odd. Okay, if you're symmetric about the origin, you are an odd function. So this function is odd. All right, going back to this graph, we have to do an XY table again, but let's do the interval right here. Again, when we do the interval, I want 5 points. So I'm going to do 2 pi divided by 4, which is pi over 2. So I'm going to go ahead and do my X and Y now. All right, so I'm going to start at 0. We're going to do negatives. So we're going to use the same values that we use for the sine because our interval is the same. All right, but this time cosine of 0. So we're going to do cosine of 0 degrees is the x-coordinate, which is 1. Cosine of pi over 2 is the x-coordinate, which is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0, and it repeats. So we have 1, 0, -1, 0. So 1, then 0, and -1, 0, and then 1. So it repeats in that cycle. So we have 1, 0, -1, 0, 1, and then repeat it on the other side, 0, -1, 0, and 1. So we can go ahead and graph it now. So -2 pi and 1, 0, -1, 0, 1, 0, -1, 0, and 1. So we can go ahead and graph this. All right, so then now we have it. So this represents one period, and that represents another period. And amplitude is that height or that depth down there. Okay. So that's one period. And notice that this is symmetric about the y-axis. So if you were to cut, this in half along the y-axis, well, it's symmetric, right? So it's symmetric about the y. About the y-axis, which means it's even. Okay, so this graph is symmetric, so we would say it's even. All right. All right, so we're going to go ahead and do the amplitude. So amplitude is 3. Again, there's an invisible 1 here, so it's just 2 pi over 1, which is 2 pi. Okay, so we're going to go ahead and graph this. We need to do the interval. I'll just use I for interval. So we're going to do the period divided by 4 if we want 5 points. So it's going to be pi over 2. So it's going to be the same kind of chart or the same x values. And we're going to do negatives and positives since that's what the graph we have contains. All right, so we're going to do cosine of 0. So cosine of 0 is 1. And then we got to do 1 times 3. Okay, so technically this is a 1 times 3. So we got 1 times 3 is 3. So that goes here. All right, so you just got to be careful because we have that amplitude of 3 there. Pi over 2. So cosine of pi over 2 is 0. So we got 1 or 3 times 0 is 0. All right, so this is going to be 0. And then if you remember the pattern, then the next one would be -1, but -1 times 3 is -3. And then 0, and then 3. And then you can continue the pattern. 0, -3, 0, and 3. So there's the pattern. And that's for y. So now we can go ahead and graph it. So at -2 pi, we have value of 3, then 0, -3, 0, 3, 0, -3, 0, and 3. We can go ahead and graph this. That part, oh no, we erased the whole thing. Okay, let's do it again. All right, something like that. All right, so So it's it looks like the same graph, but it's stretched by a factor of 3 because the 3, it does a vertical stretch. So this makes sense. All right, so the amplitude is larger here. So the amplitude is larger than it was before, and the amplitude is 3. Okay, and we forgot to label the coordinates here, but we know how to do this now. I mean, this is 0, 3, pi over 2, 0, pi negative 3, 3 pi over 2, 0, 2 pi and 3. And then we forgot to label these, but of course we can use the positive coordinates. You can use positive or negative, but I'm going to use the positive ones. All right. And looking at this is, if you were to cut it in half along the y-axis, it's symmetric about the y-axis, so it's even. All right, so let's do the last one. So we want to graph 2 full periods of this guy. Amplitude is 2, period. So this time we got a number here. So we got 2 pi divided by 1/4. Go ahead and flip to 1/4, so it becomes 4 over 1, then multiply. This is 8 pi over 4, which is just 8 pi. Let me just get rid of that. So this is going to be 8 pi. All right. So that means our interval is going to be the period, which is 8 pi, divided by 4 pieces. I'm going to choose 4 pieces. So this time each piece is worth 2 pi. So I'm going to do the XY table. All right, let's continue. So we got 0. Now each piece is going to be worth 2 pi. So I'm going to jump by 2 pi. So that's my jumps. So then 4 pi, then 6 pi, then 8 pi. That's one full period there. And then I'm going to do go backwards. So if I go backwards, it'll be negative 2 pi, negative 4 pi, negative 6 pi, and negative 8 pi. All right, so now we got a total of 2 periods, one there, one there. So we can go ahead and continue. So let's do sine of 0, but remember, sine of 0, 0 degrees is the y value, which is 0. Sine of pi over 2 is 1, then 0, then negative 1, and so on. Okay, so for the first one, we have, don't forget the 2 there. So we have 2 times 0 for the first one, then 2 times 1, then 2 times 0, then 2 times negative 1. So it repeats this cycle of 0s and 2s. All right, so the first one will be 0, 2, 0, negative 2, and 0. Repeat on the other side, continue the pattern. Negative 2, 0, 2, and 0. So at negative 8 pi, we have 0. Negative 6 pi, 2. Then 0. Negative 2, 0, 2, 0, negative 2, and 0. All right, and there's our function. Again, it's symmetric about the origin, so it is odd. All right, and that's all there is to it, guys. So go ahead and keep practicing the problems. Go look over your notes. It's really not that bad once you get the groove of setting up the table, period, and amplitude. All right, guys, have a good day.